Greetings. We are here with another episode of Chip Talk, here with Matt and Mayor Frank. We have a special guest, Paul Greer, here today, and we're going to be talking about the educational pathway of this new industry. And as Matt often says, we've gone from steel to silicon, so we're going to be talking about that. Before we go into our discussion today, Matt, can you tell us about where we are right now? Tell us a little bit about this space we're in and where we're doing this Chip Talk from today.
Sure, absolutely. So right now we're sitting in what's called the Merit Lab. The Merit Lab is a lab that's used by students as part of the curriculum here at Lorain County Community College. But this is one of several facilities here, part of the Desich Centers. So there's two buildings. The one building is where the incubator is located. The incubator is called Glide, and they have a pre-seed funding program there called the Innovation Fund. That building also has a student laboratory that's used for the associate's degree, right? And this particular lab is used for years 3 and 4. And this building also has some other functions. So I run Smart Microsystems, and our operations is down the hall, and we provide services over there. We're one of the employers that hires students out of this program, either 2-year students or 4-year students. And these labs were put here as a way to prepare the community and the region for what we view as the next wave of manufacturing here in the United States, being led by semiconductors, chips, little tiny things that function electrically, and put the smarts and all the cool gadgets that people like to have, such as their phones and their watches and their cars. And
is that one of them right there? Is that one of the pieces?
Yeah, that's one of the circuit boards used.
Are you able to touch that? Are you able to touch that?
Yeah.
Look at me. I already got you breaking things. So what does this have to do with this lab here? Are people making these? Are people breaking these? What's going on in here?
I think all of the above.
Yeah.
Is that right?
Yeah.
So the students actually, this is a printed circuit board with electronic components on it. And there's 1, 2, 3, 4, 5, 6, 7 boards here. And these boards are designed by the students, and they're assembled by the students, and then they're tested. And one of the things that I know that the faculty do is they put glitches in these designs, and the students, their job is to catch the mistakes.
Oh wow, nice.
Fix the mistakes on the equipment,
Nice.
or manually by hand.
Nice.
So not only do you learn how to design it and build it, but you learn how to troubleshoot it, and you learn how to troubleshoot the equipment.
Mm-hmm. Good stuff. So Paul, you've seen this before.
Oh yeah.
So Paul, what year are you here at the college, and what are you studying here at the college?
So I'm a junior at LCCC, and I'm studying MEMS. So this is kind of like things like this are what I kind of do on a daily basis. Like Matt was saying, one of the big parts of the degree in terms of circuit boards is troubleshooting, because it can be daunting to have a board like this that has all these different components, and then trying to figure out which one, like what's causing it not to work, because with a lot of these circuits, if one part isn't working, the whole circuit doesn't work.
Wow.
So.
And how did you get into this? What got you interested in this?
I've always had like this passion for technology since I was little. Like when I was around 5 or 6 years old, that was when I used a computer for the first time, and honestly, I didn't really know what I was doing. Like I was just kind of clicking on some random stuff, but it got to the point where I was able to open. I was like, hey, I can open up Microsoft Word. I can print something. I can search the internet, and I've been using it. Like technology is kind of become like one of the most important things in my life, and I would figure, if I want to have a career in something, I want it to be something that I'm passionate about. So
That's awesome.
Yeah, that's what led to the MEMS degree.
That's awesome. And so, from what I hear, you're a valedictorian at Lorain High School. So you're a Lorain High grad.
Yeah, 2018.
2018. And so, congrats on that. And then you shared that, you actually had saw this lab and saw this space while you were in high school. Can you talk a little bit about that?
Yeah, in high school, I was part of this robotics program, and we had like this little field trip to the college to kind of see how like kind of the work we were doing at the high school can relate over to when we kind of go into college. And so we actually, my teacher brought us into this very lab, and we got to see, we saw students doing soldering work. We saw them working the AOI machines, and it was kind of like a way of showing like this is what you can be doing a few years from now. And
wow.
Here I am. So.
Wow. Well, shout outs to that teacher. Who's the teacher that took you out here?
His name was Mr. Bogan.
Mr. Bogan. Well, shout out to Mr. Bogan for doing a good job, because it's so important to expose students at a young age to this stuff. You were fortunate at home. You had a computer at home. At 5 years old, was able to tinker around. Then you were fortunate to be at a high school that exposed you to this, for you to be able to see that. So I think there's just so many ways that, especially our schools can help support young people getting on this pathway. And you're a testament of that trip. Something happened on that trip that planted a seed with you that made you want to come back here. And how can we do more of that as a community, as a city, and as a region? But what were you going to say? I know you were trying to jump in. I'm sorry.
Yeah, that one of the things that when I talk to the students, one of the things that I hear a lot. So like when you look at this, this is not something you see every day, right? When
if you break something, you see it. If you break something open,
take
you'll
your
see
computer
it.
apart, you'll see it. But this is not something you see every day. But this is what makes the thing work. You know what I mean? So to most people, this technology is invisible. We think of the little blue sticker on the front of your computer, Intel inside, but we don't really know what that chip is or what it looks like or where it is. And one of the things that I see and I hear from students over and over and over again is when they actually see this, and you know that this is a microprocessor here, and maybe these are some resistors over here. I don't actually even know what's on this board. And there's a button here, and this is a battery holder. When you see all this stuff, and you see how small it is, it's kind of cool. It's kind of cool. And then in the class, I also know like some of these components, the students learn about what's on the inside of those components, like the chip, right?
Where are you at in terms of what have you learned so far? Like if you were to, do you know what these parts are?
Let's see.
Put you on the spot right here too.
Quiz.
I believe these parts do this kind of roll right here. They look like electrolytic capacitors to me. Like these little small.
And these things will shock you, right? I feel like I was shocked as a kid by one of these. I feel like I took something apart and I remember like my finger. Maybe I was just.
We could put a battery in it. And try it.
Yeah. Because these things, they store kind of like charge, so they end up leaking.
Yeah, I knew I wasn't crazy. I was shocked by one of these as a kid. Okay, I'm not crazy.
Yeah.
That ain't the reason I'm crazy.
Yeah, we got those are some transistors right here. I think those are NPN transistors. Not 100% sure.
I wouldn't know what you were saying anyway. If you were to tell, you could make up anything. I would just be like, oh yeah, really. So what are you learning right now? So talk to us about what you've learned and what you're learning right now through the program.
Yeah, so they kind of started me off learning like more of the physical part of like the circuit board, like the parts themselves, how they're made, how to solder them, connect them electronically, and then now we're moving into more of the software side, how to take this board and kind of design it up in a kind of we use like CAD software to kind of design like the outline of the board where the parts are placed, and then we kind of give that to a manufacturer who they take so we have what's called Gerber files, and and it's a weird name.
Yeah.
But
Gerber.
Gerber files.
Gerber files, that's what they're called.
Yeah.
Like baby?
It's
Baby
G-
files?
G- GBR.
GBR.
Oh, okay.
GBR,
No, not,
like
okay.
.gbr.
Okay,
It's a
yeah.
file format.
Yeah.
Yeah, and but so what those files are, all it really is, it's they kind of represent the, like you have like the board, and like each part of the board where all the parts go is kind of represented. It's kind of like if you took that board, you took a visual representation of it and put it into like machine code. That's all
Gotcha.
Gerber file is.
Gotcha.
And
Gotcha.
then the manufacturers, they kind of use that to actually create the boards and fabricate them.
Yeah. So one of the things that, you know, Matt and I, we've been doing these chip talks because we really believe that this is the next big wave of industry to the United States, to Ohio, hopefully to Lorain County and to Elyria. And there's a number of job opportunities that are associated with the skills that you're developing. And so have you had a chance to like visit some companies and learn about what are those career opportunities that you'll be able to use these skills?
Yeah, I've visited quite a few. There was one in LaGrange called Wetzel's, and they kind of do exactly what this is, all the soldering the boards and all of that. And I actually worked for a company the past year. It's called Technology Recovery Group, and it wasn't like one-to-one related to this, but I was able to actually troubleshoot and repair electronic devices that like certain stores use. So I would use like receipt printers, barcode scanners, handheld radios.
And you'd repair those?
Yeah, so I'd
Oh, nice.
actually I would take them apart and kind of see like the actual circuit itself. So,
Yeah, I follow this TikTok account where the guy, they mail him stuff that needs to be repaired, and he'll go in there, look, he'll be like, oh, this chip is bad here, and he'll somehow take it off and then replace it. Then he'll, you know, there's a lot of times people's iPads and iPhones.
Yeah.
Do you know how to do that? You know how to fix the iPad?
Not sure. So an iPad, no, but I do actually know how to repair, troubleshoot computers.
Oh yeah, okay. So you got a broken computer? Bring it on up. Well, Matt, talk to us a little bit about, you know, we're talking about the job opportunities and the careers, and I know an important part of the program is young people and our students, not even just young people, but any student, getting externships and internships and work experience during the program. Can you talk a little bit about the employer relations y'all have?
Yeah. So it's a very important part of the curriculum, and it was designed in from the very beginning. So Paul, you've had experiences at two different companies, correct?
Just one.
Just one? Oh, and the other one you visited?
Yeah.
Exos? Okay. So I asked the question because one of the things that Lorain County Community College has done very well is they've branched out to, I think it's like 80 some companies, right?
Yeah.
Does that sound about right? So there's about 80 companies here in the region that need people that have skill sets related to what we're talking about here. And so that does a couple different things. It shows that there's demand.
Yeah, for sure.
And these, and my understanding is it's competitive too. So a lot of these employers are competing against each other. So the starting wages are actually pretty nice. And some people I think are getting startup fees or startup sign-up bonuses. So there's a need for it right here in Northeast Ohio. The other thing that I like from the student's perspective is you have choices. That's why I asked how many companies. Because so Smart Microsystems, we hire interns just like people like Paul that come through the program. And sometimes what happens is they might work for us for, I think you have to do 300 hours or something, right?
Yeah.
300 hours. And so you
You have
might
to do 300 hours of
work.
Work experience.
to graduate.
Yeah.
Yeah, for
wow.
each, so like you have to do 300 hours for the associates and then another 300 for the bachelors.
Oh wow! You can get paid for that time though.
You get credit for it,
Okay.
and you get paid.
Okay.
for
Good.
it.
Yeah.
Good.
Yeah.
Good. I was
You get
getting
paid
a little
for it.
nervous there.
And the person that actually does the review for the credit is your supervisor. So
nice.
the faculty actually have direct feedback back into the curriculum that they use to make changes or update things.
Yep. So a company could see, hey, you know, the students that are coming over don't have this skill that I need, and they can kind of adapt the curriculum and make sure the next cohort of students.
Yeah, or they can say, hey, we need someone that's really good at hand soldering because we do repair work. And so some people like hand soldering, some people don't.
What about you?
I would be
do you
terrible.
like hand soldering?
I love it.
Yeah.
Yeah. So then what happens is the program then finds the employers that need hand soldering as a skill set, and then they identify which students are interested in that, and then they set up those internships, and they get paid. Correct?
Yeah.
Right.
Nice,
So
nice.
it's called learn and earn. So you're taking the classes, you're working, you're getting paid, and the stuff you do at work is directly related to what you just learned in class. Vice versa. Am I correct?
Yep, absolutely. Yeah, and that's the best part of it is knowing that the skills you learn in class, they can translate over to the workforce, and vice versa. You might learn some skills at work that might actually be part of more like the higher level classes you take, in the years forward. So, yeah, it's all kind of related to each other.
Nice.
It's part of the magic formula in my view. So there's a sort of a coolness about semiconductors and chips and this kind of manufacturing in a clean environment.
Yeah.
This isn't a clean room, but some of the other classroom is a clean room, and you have to gown up and wear gloves and cover your head and all these things.
How do you explain that to folks, Paul, when they ask, what are you studying, what are you doing? How do you explain it to just like family
good
members and
question.
stuff?
Kind of like explain to someone who doesn't really know what MEMS is.
Yeah, like family is like, well, what are you studying? Your 5-year-old cousin comes up and is like, what are you studying? What are you, how do you explain it?
For me, I guess the best way for me to explain it is to try to make it relatable to our daily lives. So, like you were saying, not many people really know what this is, but they know that, the circuits in your car, they have these in them, their computer, your phone. And so what I kind of tell is that, think about everything that you use on a daily basis that uses, electricity, like your microwave, even some refrigerators, a clock, they all have these circuits inside them that keep them running. And that's kind of like what I do. I build the circuit, I troubleshoot them, repair them.
Nice.
Yeah.
That's good stuff.
It's hard to explain though, isn't it?
Well, he did a great job. I mean, him saying it, I was like, yeah, I'm going to use that.
I was dying to
now.
hear what you were
No,
going to say.
I'm like,
'cause
that's how I'm going to
I could
explain
ask the
it now.
same question, like, what do you do at work, Dad? Well, it's hard to explain because people don't see this stuff.
Right.
But then when they do, it's like, ooh, this is cool.
Yeah.
This is cool.
And the
Right?
parallels that we try to draw with this industrial revolution that we're hoping happens, similar to the car, where we're in steel, and folks were building cars, building engines, building things that went inside of something that we all benefited from every day. And when I think about this chip industry, I think about, as you mentioned, it's inside of a lot of what we deal with daily, whether it's vehicles, whether it's cell phones, microwaves, refrigerators. We've had conversations about smart clothing, so there's things that are wearables that are going to be coming out. Your glasses potentially here in a couple years will have these chips in them. So it's going to be hard to live in a society without these, and so we're going to need folks that have your skill set to keep the country moving forward.
Yeah. So Paul, when we first got started, everybody was saying, oh, what is this? Why are we doing this? And like, will students even be interested? It was a little bit scary. And
I guess one of the things, thinking about that though, is like, you were able to be blessed with this experience of coming to visit this, see this, and then connect the dot. Because talk a little bit about your journey. This wasn't your first rodeo. You didn't see this and say, all right, that's the direction I'm going. You started somewhere another direction, and you said, no, I really like this, and came back. Talk a little bit about that.
Yeah, that's true because, like I said, if I were to see like these chips and all that without any prior knowledge or any background experience, I wouldn't really know what is this? Why am I fixing this and all of that? But I think it was actually that, like how I was talking about, I had this passion for technology as a kid. It kind of grew even larger in high school when I was part of the robotics program, and being able to we made so many different kind of robots, but the one we had was kind of like a robotic arm that can like it's like more of like an industrial arm that can like pick up things,
Oh,
kind of there was like a lot to it. You had to learn like the pitch and the yaw. You had to learn like the coordinate system and all that. But learning like I would say like here's the thing is not just learning all these different concepts and formulas and like math you have to do, but like actually seeing it happen and making it make something, make a light shine, or make like a robot move forward and all that. And that was that's what really made it a lot easier for me to when I did get to this program and I saw, okay, so I know like robots and stuff have these circuits, but now I know exactly what they look like. I know what the parts are. That's how now I'm seeing like the bigger picture.
Yeah, I think there's something to be said about different careers that you can go into where you can see the result of your work. And you can see when it's not working. So you can directly see by coordinating this way, it's gonna pick this hand up. That's like a rewarding thing. You see, like I figured this out, and I'm seeing the result of it. And no, that's awesome. That's awesome.
Yeah, I think that's cool. So it's the hands-on part of it is what I hear that a lot too. Like you're doing things in the lab. It's you're making things. There's a sense of gratification that comes from that. And this stuff is the college had it right. This stuff is everywhere. It's everywhere. Almost everything and anything we touch. We all know what chips are now, because there's this thing called the chip shortage. But yeah, I think the college, between the work-based learning, they started with the 2-year degree, meeting all the employers, getting the feedback from the employers, and then it's just created this huge opportunity for the students.
So Paul, how do you think we can get more students interested in this program? What do you think we could be doing as a society to help get more young people interested? And I think about your journey, because you were originally computer science, right?
Yeah.
So,
Yeah, so trying to place myself in the footsteps of not necessarily an ordinary person, but someone who doesn't really have that, like, they're not really as familiar with technology and like what it consists of. So I guess trying to show them like how the things that you like, because pretty much everyone these days, they have like a cell phone or a computer, a laptop, some sort of like maybe like a tablet, some sort of electronic device to use to, log into the internet, talk with their friends and all that. So kind of showing them, so like you've seen it, like how you've seen like it runs, it turns on, but then showing them this is what's inside of it. This is what makes it turn on. This is what makes it store all this data. And when they can see that the work that they'll be doing and like the material they'll be learning is something that can it can relate to the things they use like on a daily basis, I think that's what will kind of foster a lot more interest, because I know that was one thing for me. I play video games a lot on my computer, so being able and actually learning like all these about all these chips was actually able to help me like open up my computer, change out a part of it, change like the hard drive.
You can put the cheat codes in the hardware.
Yeah.
What did you call? You had a name for it though. Something that people do to their computers.
Overclocking.
Yeah, overclocking.
You overclock yours?
I can overclock it or like undervolt it. So,
yeah, I guess I thought I knew what overclocking
do you know
was.
How to,
I don't know what it is.
Do you know how to decap the processor?
All right, let's talk in English for a second though. Yeah. What's overclocking and what's...
Have Paul explain it. Paul explain it.
I thought I understood until I clearly used it as a verb as opposed to...
Overclocking, so that, let me try to explain it in like more of like a, not like a,
don't worry
like
about the mayor, he'll catch up.
Okay.
I'll try.
So like, like you have like the CPU and like your, like a GPU, like a...
How fast the computer goes,
let's say you have a CPU that runs at like 3.4 gigahertz, and you find, that's really not fast enough for me to do all my work. If you want it to actually go, you can actually make it go faster than what the factory settings are by if you but one way to do it is like through the BIOS of your computer. You can change, like if you increase the amount of voltage that's going through the processor, it'll make it run fast at a higher frequency, but it'll also make it'll generate more heat and use more power, more wattage. So you kind of have to, it's like a balancing act. So if you overclock, your GPU, like your CPU, you have to make sure that the temperature of
that sounds so dangerous. So you're like adding more power to something.
Yeah, because
it makes it hot.
To make it hot, then you gotta have your fans then to cool it off.
And like heat is like the enemy of electronics. Like you want your GPU, CPU, all that stuff to be as cool as possible because they actually have a lot of processors have safety features to where if they reach a certain temperature, for some it might be 85 degrees Celsius, others it might be 90, they'll start to throttle themselves. And what that means is they will lower their power consumption, so you'll get lower performance to prevent it from overheating. And then if it does reach like a critical temperature, it'll actually make the computer automatically shut off.
Wow. And what was this other thing you were talking about? Capping it, did you say?
Yeah, he's talking about the heat, right?
Yeah.
One of the ways to improve removal of heat, you can add a fan, there's other things, but you can actually take the cap off of the back of the processor, take the thermal paste out. Have you ever done this?
I have not, but that's something I've been really interested in.
Yeah. Allie has done it. And you take the thermal paste out because they use something that's cheap. And then you can get this stuff at the hardware called, I think, liquid metal or something like that.
Yeah.
You squirt it in there, you let it dry, you put the cap back on, and then you can overclock it, and it has better heat conductivity.
Oh, wow.
Yeah.
Well, yeah, I'm looking forward to learning this stuff at some point.
You are in a classroom right now.
Yeah, no doubt. I think you made me think about in the city of Lear, we're opening an esports arena. And so it'll have all these tournaments and competitions. So I'm sure people who come to that will know exactly what you're talking about, and they'll know, how to overclock and make things, perform at its optimum. So, I'll get there someday. But Paul, what do you think is important? As we start to wrap up, what do you think is important for, that young person in the city of Lorain who's trying to figure themselves out and what direction they want to go in life? What would you like them to, know about your experience? You went off to OSU, you studied computer science, you came back here to LCC, you're studying MEMS, you've had this great experience, you're using your skills. What do you think is important for them to know from your perspective that not only they should know, but their parents should know as well?
So in terms of like knowing like what career path or like what kind of major they want to go in, I would say this is always what helps me is you'll have all these different opportunities and exposure, but I would say the most important part to finding like what really clicks with you is to like try to find something in your daily life that you do. It might be you might really even like if you really like basketball or something like that, something that where you can see yourself. Like if I was to do this like every day, 8 hours a day, Monday through Friday, and not get tired of it, and I know like it's hard because there's so many different career paths. Like you'll have like even with MEMS you can be a solid technician, you can be a draftsman, you can be a designer, and but I would say throughout all of that, the most important part is knowing what makes you happy, because if you let's say I was going to like the MEMS, learn how to do all this stuff, if it wasn't really like, if I was learning it, I was absorbing all the knowledge, but I wasn't really enthusiastic about it, I wasn't really enjoying it, I don't think I would be nearly as successful as I am.
That's awesome.
As I am, because it's like you'll make it to the point where like you look forward to learning, it's fun.
That's awesome.
So, yeah, but whether for some people, for me it's technology, for someone else it might be, they might want to be like a civil engineer or a nurse, a doctor, just find that thing that really, that it just kind of makes you just like
light up.
Yeah.
You
Yeah,
you
light
lit
up.
up right here.
Yeah.
Yeah, no doubt.
Yeah.
No, I appreciate you sharing that. And Matt, one of the things Paul just mentioned was there's so many different careers within this space. Can you talk a little bit about it? It's not just the soldering part. There's so many different aspects of this field.
There's so many different aspects. So this is just one glimpse of what semiconductors and electronics is. So Paul, actually, you described it pretty well. You may not be that soldering person, but you could be a design person. You could work in a wafer factory. You could do, at Smart Microsystems, what we do, we call it packaging. So we're taking bare chips and putting them into components that end up later on circuit boards. So the semiconductor supply chain is very wide and diverse. And so some people, it's chemistry and materials. You know, like this printed circuit board material, this green stuff, that's a highly engineered material. And actually within this board, there's layers. And I don't know, maybe it's 4 or 5 layers. I don't know what the routing looks like. This is highly engineered. So some people just make boards. Some people make the components. And for each one of these parts, someone's got to do the design. And somebody has to do the testing, somebody has to do the manufacturing. So there's lots of different things that you can do. And again, it's one of the things I think the program does very well with is if I can go work at this company for a few 150 hours, and then I can go and do 150 hours over at this place, and then you could do the same thing in year 3 and year 4. You could actually have 4 different working experiences in this technology space at 4 different companies right here in Northeast Ohio.
That's awesome.
You can pick and choose. Like, I like doing that better than this, but I did that. I know what it is. So you know, that kind of thing.
Yep. No, that's one of the powerful pieces about this industry coming here to Ohio and again Lorain County and Elyria is that it's going to open up so many job opportunities. And like, you know, in every industry there's human resources, there's financial management, there's the marketing. So there's going to be so many opportunities. We're just hoping that our city, our county, our community takes advantage of it. And I'm excited to hear, Paul, you're taking advantage of the opportunity, getting your education and you know, using something that you're passionate about and finding your lane. And we're hoping that more residents, more young people, more people who are career changing take a similar path and take advantage of this great opportunity. So thanks for joining us for this Chip Talk, and looking forward to following your journey for years to come.
Yeah, my pleasure.
Thanks,
Thank you.
stuff, Ralph. Yeah, sure.
Thanks, Paul.
Good stuff. It's another episode of Chip Talk.